the resistance thermometer. Resistance thermometer. Put a question mark. I repeat, explain briefly with neat sketch resistance thermometer. Put a question mark. List the advantages and limitations. Advantages and limitations. Very first question in the second portion of module 5, almost all the question paper, you have a question on resistance thermometer. All of you please mark it, very, very important. This is the principle of working of resistance thermometer. Next come to the points, very, very important. Almost all the question paper, you have a question on thermocouple. What is the definition of thermocouple? Say, see, all of you observe here. This is the wire A made of copper alloy, and this is wire made of silver alloy. Remember, the metal A is made of copper alloy and metal B is made of silver alloy, and which is connected to ordinary galvanometer or voltmeter. And voltmeter, the junction, that is the joint of these two different wires are connected at the point here. This is junction P, and here the metal A and metal B is connected, making the junction. This is called cold junction. Usually this cold junction is placed inside a flask which contains the ice cube, The temperature of the ice cube is minus 6 degree centigrade. Minus 6 degree centigrade. This junction Q, all of you observe here, this junction Q serve as a cold junction, and this junction is under the lamp which provides the heat to this junction. This junction works as the hot junction. Remember, the difference in metal A and B, the difference in temperature from cold junction to hot junction, and EMF is generated in the circuit that can be measured by using voltmeter. That is called thermocouple. That is called thermocouple. Once again, metal A is copper alloy, metal B is silver alloy. These are the wires or thermocouple wire. Connect the metal A with the voltmeter like this. The ends of the metal A and metal B made the junction. By twisting this junction by soldering process, make the junction B. This is under the lamp. This works as a hot junction. And next come to the point. Another point, this is the cold junction, which is placed inside the flask, which contains the ice cube. What is the temperature of the ice cube? That is minus 6 degree centigrade. The cold junction and the hot junction. The hot junction is temperature T1, hot junction temperature T1, and the cold junction temperature T2. Remember carefully, all of you listeners here, this is very, very important definition of the thermocouple. The difference in metal A and B, that is copper alloy and this is silver alloy. These two wires are made the two junctions. One is hot junction. The wire is twisted, soldered, and placed on the lamp, which provides the heat to this junction. This junction serves as the hot junction. And this point is twisted, soldered, and placed inside the flask, which contains the ice cubes. This junction works as the cold junction, which is at the temperature minus 6 degrees centigrade, that is T2. T2 and the metal A is connected to the voltmeter like this. Then definition of the thermocouple, the difference in metal A and B, the difference in temperature T1 and T2, and the difference in hot junction and the cold junction. Due to this, an EMF is generated in the circuit that can be measured by using voltmeter. Millivoltmeter. The millivoltmeter is gives the reading in millivolts. That is, the manufacturer of the thermocouple provide the chart. From that chart, you can directly measure the temperature of the hot source of anything, maybe boiler, maybe furnace, or maybe welding. So that can be measured from the making the circuit like this. We can measure the temperature of the hot junction through this circuit. That is the application of thermocouple. The manufacturer of the thermocouple provide the chart. There you can millivolts is converted into degree centigrade or degree Fahrenheit. You will get the direct answer. For 1 millivolt there will be 2 degrees centigrade or 3 degrees centigrade. Direct conversion is available in the table for a particular millivolts answer result. For that, you have the temperature. So, all of you observe here, this is the commercially available thermocouple. All of you observe here, red color and the blue color. Red color is the copper alloy and the blue color is the silver alloy, and these two are connected by the junction. If you want to measure the temperature of the metal, liquid metal inside the furnace, you have to keep this in the furnace so that you can measure the temperature. That is the application of thermocouple. Thermocouple. All of you, please write down. Afterwards, you write down. Next, come to the point. The laws of thermocouple. Almost all the question paper, you have a question, law of thermocouple. This is very, very important. Law of thermocouple. And the law of thermocouple is divided into two. One is the law of intermediate metal and the law of intermediate temperature. That is, if you use the measuring instrument or if you use different metal in the circuit, so that the net EMF produced in the thermocouple circuit will not change. First come to the point, law of intermediate metal. Say this is the metal A, this is the metal A, and this is metal B, and you have inserted metal C, and this is the temperature T1. It is placed in the hot junction, that is in the furnace at about temperature 1500 degrees centigrade. And here this junction is placed inside the thermos flask where the temperature is minus 6 degrees centigrade. So if you use the intermediate metal, if you insert third metal, the metal A and metal B, so the net EMF produced in the thermocouple circuit will not change. The EMF remains same. EMF remains same. This is very, very important. The EMF remains same. If you introduce third metal in the circuit, will not affect the net EMF produced in the circuit. Next, come to the point, the law of intermediate temperature. Suppose the metal A at the temperature T1 and the metal B at the temperature T2 and the metal junctions A and C at the temperature T3. At the temperature T3. Then the intermediate temperature will not affect the net EMF produced in the thermocouple circuit. Net EMF produced in the thermocouple circuit. The laws of thermocouple circuits are law of intermediate metal and law of intermediate temperature. Please, all of you write down question. You can write. This is a very important. This time you can expect this question in the examination. 100% guarantee you have this in the question. You have this question in the examination. Write down. You have this question for 10 marks. So all of you remember. So write this diagram and this diagram and write law of intermediate temperature and law of intermediate metal. And write down the question. What is thermocouple? What is thermocouple? Put a question mark. What is thermocouple? A question mark. Explain briefly. Explain briefly. The same type of question you have in the examination. Next line, write down one more question. This you have the same question in the examination. Explain briefly. Explain briefly. Loss of thermocouples. Loss of thermocouples. Loss of thermocouples. So you have this question in the examination, 100% guarantee. First definition of thermocouple. For this, you write this diagram. Next, for laws of thermocouple, write down law of intermediate metal and law of intermediate temperature. That is nothing but if you introduce the intermediate metal C in the circuit, will not affect AFFECT, will not affect the net EMF produced. And the next law is, second law is intermediate temperature. See, junction P is at T1, junction T2 at Q is at T2, and again the junction made by metal C and metal A at the temperature T3. The introduction of a third temperature T3 will not affect the net EMF produced in the circuit. Net EMF produced in the circuit. So this is the explanation for law of intermediate metal and the law of intermediate temperature. This much is enough for this class. All of you, please write down your name and USN in the chat box. All of you, unmute yourselves. Answer roll call. Answer roll call. All of you, unmute yourself and answer roll call. Smoke RJ. All of you, unmute yourself. Sumuk RJ. Sumuk Raj. Nitin LM. Nitin LM. Pawan P. Vinayak JH. Pritam D.
Present, sir.
Vinayak A. Swati DN.
Yes, sir.
Rahul MP.
Present, sir.
Prithvi Mahesh. Prithvi M.
Present, sir. Present, sir.
Pawan
Prithvi Mahesh.
P. Mohammed Harris.
Yes, sir.
Sagar M.
Yes, sir.
Shashank HS.
Present, sir.
Siddharth HR.
Present, sir.
Anybody else? Please tell me
Sir,
your
Sumuk
name.
Raj. Sir, Sumuk Raj.
Okay, next.
Sir Sandesh.
Anybody else?
Sir Sandesh.
Okay, I stop at this stage. I will continue in the next class.